Consider a step shaft subjected to twisting moment of 100 Newton meter applied at B as shown in the figure. Assume the shear modulus G is equal to 77. The angle of twist at C we have to find out. As shown in the figure, at C there is no torque is acting. So for the portion BC the torque will be equal to 0 and the torque is remain constant equal to 100 Newton meter for the portion AB. So this torque is equal to 100 Newton meter and this is the only torque acting. We'll take this value as a positive value. Since at C there is no torque acting, so portion BC has no torque. So torque in the portion BC will be equal to 0. So torque in BC will be equal to 0. 100 Newton meter we'll treat as a positive. So from this point we'll move vertically upward and we'll show this torque is equal to 100 Newton meter. No torque is acting between A and B, so this torque is remain constant between A and B. So this one is the torque for AB and this value is same as 0 plus 100 equal to 100. And our reaction torque is same as equal to 100 Newton meter at point A. So reaction torque is TA will be equal to minus 100 Newton meter. As far as the point A is considered, the value of theta A will be equal to 0. So we have the relative rotation of B with respect to A. So theta B with respect to A will be same as equal to the torque multiplied by length divided by J multiplied by G for the shaft AB. Theta B with respect to A will be same as theta B minus theta A. Torque is equal to 100 Newton meter is 100 into 10 to the power 3. Length is equal to 500 divided by pi by 32. So 32 will shift in numerator. Divided by d to the power 4. D is equal to 20. So we have 20 to the power 4 into modulus of unity G, which is equal to 77 giga. We have to use mega, so we will multiply by 10 to the power 3. So theta B value we can calculate from this equation. Theta A is a fixed end, so that equal to 0. Right hand side you will get here is close to 0.041. That will be radian. So in this case we have theta B will be equal to 0.041. Similarly, we can calculate the relative rotation of C with respect to B. This is calculated using the formula TL by J into G. And you have to use this section as BC section. So this value is same as theta C minus theta B. And this time the torque BC is equal to 0. So right hand side will be equal to 0. So we have theta C will be same as equal to theta B and is equal to 0.041 radian. In this case the torque in the section BC is equal to 0. And finally we have to give this answer in degree. So we have 0.041 multiplied by 180 divided by pi radian. So approximately in degree this answer is close to 2.36 degree. The step shaft of a uniform material with a shear modulus of 10 to the power 5 megapascal is shown in the figure. The length and the polar moment of inertia are given. Assume a torque of 5000 Newton meter is applied at the free end. The twist at the free end we have to calculate. So this end is fixed. So we have shaft 1 and shaft 2. Since the only one torque is acting, so torque is remain constant over the entire cross section. So at point C we'll move vertically upward by 5 kilonewton meter and no torque is acting either at A, B or C anywhere. So this torque is remain constant. So in this case we have torque T1 is same as equal to T2 is equal to 5 kilonewton meter and the reaction torque at A is same as equal to 5 kilonewton meter. Now theta A will be equal to 0, so directly we can calculate here the total twist at the free end theta will be the sum of theta 1 plus theta 2. That is, we have T1 L1 by J1 G1 plus T2 L2 by J2 into G2. Here torque term is remains same, value of G is remains same. So we'll take out here T and G common. What is left is L1 by J1 plus L2 by J2. Torque is equal to 5 kilonewton meter is 5 into 10 to the power 6 divided by G. G you have to take as 10 to the power 5 megapascal into L1. L1 is equal to 1 meter. 1 meter is 1000. Actually that will also taken common. Let's forget it. We have IP1 is a J1 value is 25 cm to the power 4. So you have 25 into 10 to the power minus 4. 1 cm is equal to 10 mm. We have 1 cm is equal to 10 mm. So we have cm to the power 4 will be 10 to the power 4 mm to the power 4. So plus again we have 1000 and the polar moment of inertia for the second shaft is 10. So we have 10 into 10 to the power minus 4. Solve this. You will get the total twist at the free end that will be equal to 0.7 radian. A torque T is applied at the free end of a step shaft of the cross section as shown in the figure. We have diameter equal to 2d, length equal to L, diameter equal to d, corresponding length equal to L by 2. Only one torque is applied, so torque is remain constant throughout the cross section. The shear modulus of the material of the rod is G. The expression for D to produce an angular twist theta at the free end you have to find out. In this case you have to find out the value of D in terms of theta and you have to select the proper equation. So first of all we'll calculate here theta. This one is shaft 1, this one is shaft 2. In this case only one torque is applied, so we have T1 is same as equal to T2 is equal to T. So we have total value of theta will be equal to theta 1 plus theta 2. That will be equal to T1 L1 by J1 G plus T2 L2 by J2 G. T1 and T2 are same, so that can be taken common. So we have T by G is common into L1. L1 is same as equal to L and 32 in the denominator will shift in numerator. So we have 32L divided by pi. Diameter for the first shaft is equal to 2d. So we have 2d to the power 4. Then we have again 32. Length for the second section is L by 2. So we have L divided by 2 divided by pi. Diameter of the second shaft is only d. So we have d to the power 4. So at this stage we will take out here 32 common. L common, d to the power 4 common. So we have 32 times t multiplied by L divided by G, d to the power 4 common. Even we can take out pi common. Here we have 2 to the power 4 in denominator is 1 by 16 and here 1 by 2. So we'll calculate here LCM that equal to 16. So we have 1 plus 8 that is equal to 9 by 16. So we have 9 divided by 16 into 32 divided by pi into t into L by pi into G d to the power 4. 16 and 32 will be equal to 2. 9 into 2 is 18. So we have 18 times t into L. I think we have repeat the pi term here divided by pi into G into d to the power 4. 18 TL by pi theta G. So this value is theta. So d we have to find out in terms of theta. So we have 18 times T into L divided by pi into G into theta, and whole power is 1 by 4. That is, choice B is correct. A bar of a circular cross section is clamped at end P and end Q. It means that we have value of theta P and theta Q will be equal to 0. A torsional moment of T is equal to 150 Newton meter is applied distance of 100 mm from the end P and remaining distance equal to 200. The torsional reaction Tp and Tq in Newton meter at the end P and Q we have to find out. So the external torque applied here is equal to 150 Newton meter. So this one is 150 Newton meter. The reaction will be exactly opposite in the sense of a external torque. So we'll show the reaction in opposite direction at point Q. So this one is our TQ, and same reaction we'll show at P also, that equal to TP. So that these two external reactions will be cancelled. The torque TQ. This one is shaft 1 and this one is shaft 2. So this one is a problem of statically indeterminate problem. So we have twist at point P will be equal to 0, twist at fixed end Q will be equal to 0. And in the shaft 1 plus shaft 2, total twist will be equal to theta 1 plus theta 2 must equal to 0. So this one is called as compatibility equation. This value of the torque will take it positive and the other two will be taken as negative value. And remember here the sum of Tp plus Tq is together equal to 150. So we'll show your torque diagram and we'll develop the relation between T1 and T2. At this fixed end we have reaction torque is negative, so we'll move it downward and we'll represent this torque is equal to minus Tq. So this torque is remain constant between R and Q. So you have to draw horizontal line and we have value of T2 is equal to minus of Tq. Then suddenly at point R we have positive value is equal to 150. So we'll move vertically upward from this point to this point and the total distance covered will be same as equal to 150 Newton meter. So this torque is 150 Newton meter. So between P and R the torque is remain constant. So this value will be representing the T1 value. T1 value is same as equal to the sum of the previous two value, that equal to 150 and minus Tq. And same value of T1 will be the torque at point P. So we know T1, we know T2, and we have theta 1 plus theta 2. In this case we have theta 1 is replaced as T1 L1 by J1 into G1 plus T2 L2 by J2 equal to 0. Diameter is shown uniform, so we have D1 equal to D2. Metal property will say take as the same value, and since diameter is same, polar moment of inertia remains same. So this denominator will be get multiplied with equal to 0. So we have T1 L1 plus T2 L2 equal to 0. In this case we have T1 is equal to 150 minus Tq, and we have length L1 is equal to 100 plus we have T2 which is equal to minus Tq into L2. L2 is equal to 200 equal to 0. Expand this. We have 15000 minus 100 times Tq minus 200 times Tq equal to 0. So total we have 300 times Tq equal to 15,000. So we have Tq is equal to 50. And we'll continue the unit as Newton meter. We got the value of Tq, so we can calculate here the value of T1. And remember the T1 is same as equal to Tp value also. So we have Tp is equal to T1, which is equal to 150 minus 50. That is equal to 100 Newton meter. I will give the quick solution so that we can save the time, because this one is a common problem appear in the GATE examination. If you want to calculate the value of TQ, then you can calculate TQ as the total length is 300 and opposite length is 100. So is 100 upon 300 multiplied by external torque equal to 150. That is 1 by 2 of 100 equal to 50. So in one simple step we can solve this. And if you want to solve the value of Tp, then opposite length equal to 200, total length equal to 300 multiplied by external torque equal to 150. So this one is divided by 2, 200 by 2 and equal to 100. So within a second we can find out such type of answers. But remember, it's a quick step. Just remember here that whatever the shaft we want to find out the value of reaction, you take the opposite length divided by total length multiplied by external torque. But this rule is applicable only when we have D1 is same as equal to D2, and therefore we have J1 is same as equal to J2, and we have G1 must equal to G2. Then only this shortcut formula is applicable. So same question again asked in GATE 2009 exam. This time we have given the length equal to L by 4 and 3L by 4, that is 0.25 times of L and 0.75 times of L. A solid shaft of diameter D and length L is fixed between the two ends. Torque T0 is applied at a distance equal to L by 4 from the left end. What is the maximum shear you have to calculate? So in this problem, first you have to find out what is the torque developed in the portion 1. So this one is representing the section 1. This one is representing the section 2. We have a uniform diameter D1 equal to D2. Even the value of G is remains same. So this one is the external torque. Exactly opposite sense will show on the end, that is both end. Let's say A, this one is B and this one is C. Now the torque applied at the end C is the reaction torque. We have shown is opposite direction. So we'll show this one in downward direction, that equal to torque equal to TC. Then the torque is remain constant between B and C. So this torque is remain constant between B and C. Let's call this one is T2, and T2 is same as equal to minus TC. Then we apply a torque equal to T0 at B, which one is a positive torque. So we'll move vertically upward. So this value is same as equal to T0, and then between A and B there is no torque acting. This will be same torque equal to T1. This time the value of T1 will be same as equal to T0 minus TC, and this torque is same as the torque at A. So you have to close this diagram. Since here both ends are fixed, so this one is representing the statically indeterminate problem. The twist at A and C will be equal to 0. So we have theta 1 plus theta 2 together is one is positive and one is negative, must equal to 0. So we have T1 L1 by J1 G1 plus T2 L2 by J2 J2. Diameter is remain same here, and the value of G is remain same. So we can write this value as T1 into L1 plus T2 into L2 equal to 0. Using this we will find out here whether the T1 is more or T2 is more. Sign doesn't matter. We have T1 value is same as equal to T0 minus TC. Length L1 is same as L by 4 plus T2 you have to take as minus TC, and L2 is equal to 3L by 4 equal to 0. So this 4 and this 4 is multiplied with 0, and L will be get cancelled. So we have T0 minus TC minus TC multiplied by 3, that equal to 0. Total we have 4 times of TC equal to T0. That is we have TC is equal to T0 divided by 4. Hence we can calculate the value of TA. So we have TA equal to T0 minus Tc, that is T0 minus T0 by 4. That will be same as 3 times T0 by 4. This result we obtained the orally also. If you want to find out the reaction at this point C, then we have L by 4 divided by total length equal to L multiplied by T0, that will be equal to T0 by 4, and this value will be opposite length is 3L by 4 by total length equal to L multiplied by T0 is 3 by 4 of T0. So this one is the oral answer we can obtain if we have D1 equal to D2 and G1 equal to G2, but we are interested in the maximum shear. So out of Tc and Ta is a maximum value. So this will be Tmax, and Tmax is equal to Ta is same as equal to T1. So we have maximum shear in the shaft AB, and this maximum shear we can obtain as torque is equal to pi by 16 into d cube multiplied by tau max. We have to take this value as Ta value or T1 value is one and same. So we have 3 times of T0 divided by 4 is equal to pi divided by 16 multiplied by d cube multiplied by tau max. So this 16 and 4 we are left here with 4. 4 into 3 is 12. So we have tau max will be equal to 12 times T0 divided by pi d cube. 12 times T0 divided by pi d cube, 12 times T0 divided by pi d cube, choice C is correct choice. Let me give you the idea about the reaction. At C, if you want to find out by quick method and if you satisfy this condition, then it's a L by 4 divided by total length equal to L multiplied by T0. That is T0 divided by 4. This one is a quick method. And if you want to find out TA, then we have TA equal to opposite length equal to 3L by 4 divided by total length equal to L multiplied by T0. So we will get this value equal to 3 times T0 divided by 4. You don't have to do this analysis if you satisfy this condition. And once we know that this value of TA is more as compared to TC, then we can find out here the maximum shear. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.